Okay, so let's talk about some acids. Acids are going to be defined by your polyatomic ion or the ion that you're working with, right? And so remember, I think we talked about this. I ate organic apples. I was going to say acids, despite them being poisonous. I ate organic apples despite them being poisonous. And the first thing that comes to mind, I am not talking about Snow White. I'm talking about how you name your acids. This is a little called an anagram, I believe it's called. So I ate. So if it ends in ATE, so if you have that root, for instance, I'll write a thing up, I'll write a formula up. Let's say, use the same one I used yesterday. I have H3PO4. So you guys see this beautiful polyatomic ion that's in here? Which polyatomic ion is in this complex?
PO4.
In this compound. What was it? I'm sorry.
PO4.
PO4. And that guy's called what?
Phosphate.
It's called phosphate. So I see my PO4 and I say, oh, damn, that's phosphate, right? So phosphate. So that means this acid, even though I didn't put my AQ on there, Jessica was going to start screaming at me in a minute. I don't know which one, maybe both of them.
Wow, Dr. Henry, how dare you not put aqueous?
Okay, so I see phosphate, right? I ate organic. Oh, damn, I see, right? So what is my acid going to be called? So I'm going to get rid of that 8, and then I'm going to put in an IC somewhere.
It's going to be the phosphoric acid.
That's right. Okay, so I put my IC, so I use that phosphorus. I drop that 8, so I get my OR back, and then I put IC at the end, phosphoric acid. So this acid is called phosphoric acid because I saw that phosphate in there. You guys get it?
Yes.
Okay. Now, despite them being poisonous, and you're probably at this point, so why do I need to know about all that despite stuff? Well, despite ITE, I'm going to substitute with OUS, and I'm going to put an acid at the end. So if I have So if I have SO3, what is that guy called?
Sulfite.
It's called sulfite. So the SO3 part is called sulfite. So then the acid, since it has that H in front of it, that balances it out, the acid is going to be called
Sulfurous acid.
I am so furious with you. Sulfurous acid. Okay, piece of cake?
Mm-hmm.
Mm-hmm.
Okay, so now you guys got this, right? You got this under control? Like, I got this now, right? Simple. I remember I ate organic apples despite them being poisonous. Okay, so let's test this out. Let's say I have something like this. Hold on 1 second, please. Sorry, I thought it was the company. So let's say I have this guy here. Oops. Okay, what would this guy be called? Or we'll put one more up there too.
Would it be hydrochloric acid?
Nope.
Would it be hydrochloroxide?
Hold on 1 second. I forgot. I have my AQ here. So, but it wouldn't be hydrochloroxide either. And this guy has a okay. Okay, so tell me, what is the polyatomic ion that we see there? Is there one there?
Hypochlorite.
Hypo, is it hypochlorite or hypochlorate or hypochlorite?
Hypochlorite.
Hypochlorite. Okay, so we have hypochlorite. This guy here is hypochlorite. Okay, so I have hypochlorite. So what am I going to call it?
Hypochlorous.
Hypochlorous. Excellent. So I call it hypochlorous acid. Simple. Come on, Siobhan, you have to tell me it's simple. Because if you don't tell me it's simple, then I'm going to be hurt.
I said yes, but I was on mute.
Okay. Okay, so what about the guy below it? Oops, and this is wrong too. I forgot this guy. There's a 3 there for the H. Boop, 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 boop.
Could it be perarsenate?
That
Oh,
per
arsenic.
arsenate. Okay, so we have per arsenate. So then what would be the acid?
For arsenic?
Per arsenic. That's right. Per arsenic acid. Don't forget the acid part. It sucks to get all the way and then Oops. That's so funny because if you look at the name, it just puts an IC at the end of it anyway, right? Because it's arsenic.
Yeah.
So it's just per arsenic acid. Simple?
Mm-hmm.
Okay. Everybody got it? Not too hard?
Not too hard, but I have a feeling you're going to say ready for it to get harder.
Are you ready for it to get harder? God. Okay. You guys know me so well. So let's see if we can make it a little more challenging. I'm going to give you another anagram. Let's see. My ride has hydraulics. How do you spell hydraulics? Well, we're going to spell it wrong anyway.
So it's Loulcs.
Okay, so it's totally misspelled. Hydro. That's what I'm trying to get. It's going to be my underline. And Ide. Okay, so if I have H, this meeting is being recorded. So you guys figured out that you guys can record it on your side too?
Mm-hmm.
Excellent. Okay, so if I have this guy, the way I would name this guy is, because it's sulfide is my ion. Right, because isn't that called sulfide? Could have asked you.
Oh, yes.
So sulfide is my ion. So then I say hydrosulfuric acid. You guys see that? So hydroic. So if I use the word hydro, it just refers to the hydrogen, and there's no oxygen in it at all. Okay, and I use ic. Okay, so I'm going to ask you about this guy. Let's see. Not want to behave. Okay, this guy here, that's an AQ. It's not the prettiest AQ. What would I name this guy?
Phosphide?
Nope. It is a phosphide. So if it's phosphide, then what am I going to name it? What is the acid going to be called?
Hydrosulfuric acid?
Hydrosulfuric acid. That is correct. So then we call this guy hydrophosphoric acid. Simple? Yes, no, maybe?
Maybe.
Maybe. Okay, let's say if I have this guy. Okay, what am I going to call it?
Would it be dihydrogen phosphide?
Nope,
It's an acid, right?
it's an acid. What is it? The acid going to be named?
Okay.
Now look at the letters. It's important that you look at the letters.
Dihydrogen phosphoric acid?
Nope.
It's polonium.
What is PO?
So it-
Po? What is
polonium.
Po? Polonium.
Hmm.
What is
So it's not a phosphorus, so it's polonium, right?
Yeah.
Okay, so what would I name it?
hydropolonic acid?
Hydropolonic acid.
Bye, baby. Have a good day at school.
Okay, now, so Matt is kind of bringing up something indirectly, even though he was mistaking polonium for phosphorus because he saw that P and he was just ignoring that O, right, Matt?
Yeah.
Yeah, can't do that, right? You got to pay attention to all of the symbols on there. That's important. That's one thing. The second thing is, so AQ and the H kind of go together. That always reminds me that it's an acid, unless I'm told, like on your homework, you guys are told that these are acids. So then you don't have to put the AQ there. You understand? But otherwise, you want to put an AQ to remind us that it's an acid, because if you write it as this, say we just, it could be a gas.
Oh, yes.
And then, so what would this guy be called? Would I still call it hydrophosphoric acid? Oops, sorry. No, because in this case, when it's a gas, it's a covalent bond. Here, these guys are an ionic bond because you're actually adding an H plus, 3 H pluses to that phosphorus or that phosphide. Somebody had a comment. Okay, let me fix my 3 there. Looks like a, I don't know what that looks like. Okay, you guys see that? I'll move all the other stuff over in a second. I'm struggling here. Okay, do you guys see it? So 3H pluses, which is a hydrogen ion, it's going to balance out the phosphide ion, and so it comes together to form our hydrophosphoric acid. Okay, so where this guy here, over here, you see this one here over here, this one is a covalent bond. So how would I name this guy based upon what you guys know?
Would it be trihydrogen phosphide?
That's right. Because it's a gas, it's letting me know that these guys are covalently linked. So your acids won't be in the gaseous form, right? Because they form covalent bonds in that context. Okay? So then you would call this guy trihydrogen phosphide. So do you guys see the distinction? So one is acting as an ionic reaction, an ionic bond, and one is acting as a covalent bond. So this is the funny thing about hydrogen, because hydrogen can go from either way. When it's in solution, when it's aqueous, it's going to act as the ionic bond. When it's not in solution, when it's a gas, then it's going to act as a covalent bond. Do you guys get that? So that's part of the reason. Have you guys noticed where hydrogen is located at on the periodic table? Anyone ever noticed that?
Hydrogen.
Yeah.
Hydrogen.
You see my screen? Where's hydrogen located at? Which group?
The first one.
Group 1, right? So what do we know about group 1 metals? What do they do when they form ions? What charge do they take?
+1.
+1. Guess what? Guess what hydrogen does when it's in solution? And it's with a non-metal. Guess what charge it takes? Come on, it's not too much of a leap. It's in group 1. What do you think it's going to do?
+1.
+1. So it becomes +1. So let's talk about this +1. So if it's H plus, how many electrons does it have?
0.
Excellent. It has 0 electrons. How many protons does it have?
1.
And how many neutrons does it have?
0.
Who is that?
1.
Juan? Excellent job, Juan. Didn't recognize your voice. Okay, so we often will call H plus a proton donor. Can you see why? Hello? Are you there?
Because electron
Because it
donations
has
are
one
0.
proton.
That's right.
And it
And the
has
only
one
thing that's
proton.
left is what?
The proton.
A proton. So that's why it's called a proton donor. So acids in general are proton donors, meaning that most acids will separate and then they'll donate that H plus to somebody. Okay? So in reactions, acids are often considered to be proton donors. They're getting rid of their H plus and they're giving it up to somebody else. You guys get that?
Yeah.
In most cases. Okay, so often you'll read a lot of literature and everything like that. Acids are proton donors. Now you know why we call it. Okay. Okay, so are you feeling comfortable with naming acids? My ride has hydraulics and the whole thing with apples. Okay, so let's see. We'll see how well you guys understand what you guys have been taught about nomenclature. We have one more thing to go over, and that's hydrates. Hydrates are so hard. I don't think anybody will ever get the hydrates because they're just so difficult. You want to learn hydrates first, and then we'll play a little game, have a little competition, because life is boring without competition. Are you guys there?
Good. Yes.
Okay.
Yeah, we're here.
Okay, so let's talk about hydrates since we talked about acids, and then we'll also talk a little bit more about acids because acids are so much fun. Okay, so let me get to a whiteboard. Okay, so are you guys good here? Good? Give
Yeah.
or take?
Yep.
Okay. I'm gonna clear my screen. And we're gonna talk about hydrates. I'm gonna say hydraulics. Hydrates. Okay. So let's say we have something like this. We'll do. I don't know how to do this the right way, so we'll do it the wrong way. Okay, so we have something like this, right? This is called a hydrate. Hydrates are basically, they're moistened with water often. And so they have 6 waters to every one, in this case. To every one of these compounds. So for every one of these compounds, there's going to be 6 waters to this guy, right? So there's 6 waters that will surround it to kind of keep it moist. Often we will hydrate solutions to make them easier to dissolve. Okay, later on. So they'll still come in a powder form, but it'll be kind of a wet powder form. Do you guys get that? Yeah, no, maybe. You understand the word hydrate? So if you're hydrated, that means what?
Water.
Water.
Plenty of water.
Plenty of water. So if you're dehydrated, you're what?
And
Losing water.
lacking or
You're lacking water, right? Okay. So we'll use another term for dehydrated. We'll say anhydrous. Anhydrous means no water, okay? Okay, so we have this guy. What would we name this guy? That's a 4, not a 9. Fix it so it doesn't. Okay, what will we name it? Just this part here, the first part. What is that guy called?
Potassium permanganate.
Potassium permanganate. Okay, so since it has 6 waters attached to it, what is the Greek prefix for 6? And we just attach the word hydrate. So this guy would be called potassium hexahydrate. Piece of cake? Okay, so we have this guy.
Uncle Henry, are we supposed to have an A between the hex and
Yeah.
hydrogen?
You're right, there's supposed to be an A here. Thank you.
Sure.
Did you call me Uncle Henry?
I said doctor. Oh, sorry. I'm sorry.
That's okay.
Dr. Henry, I'm sorry.
Nobody needs to know that you're my niece. It's our little secret.
I have an uncle whose name is Henry too, so we call him Uncle Henry. I have an uncle whose name is Henry, so we call him Uncle Henry.
Okay, so what would I call this guy? Oh, let's use a different, let's not use 6. Can't remember which one it is. I actually do think it's 6. We're gonna use 8. So what would I call that guy?
Could it be
Iron.
iron chloride?
Nope. It's not iron chloride.
Chlorate.
Iron
Nope, it's
chloride.
not iron chlorate because there's no oxygen in there.
Oh, okay.
Iron 3.
There we go. Is it chlorine? Did you say chlorine 3?
No, iron 3.
Iron 3. It's iron 3 what?
Chloride.
Iron 3 chloride.
Mhm.
Oh, because it's a trend.
That's right. It's a transitional metal. And then what?
Octahydrate.
Octahydrate. So I lied when I said it was the hardest, right? Because all you have to do is add on that water to the ion. Iron 3 chloride octahydrate. Piece of cake? So let's say we did a reaction. And we got this. We boiled it. So this guy now, instead of just calling it potassium permanganate, we'd have to call it he's getting excited.
I know he's like really talkative in the mornings.
It's because he likes
Sorry.
chemistry. He's gonna be a chemist. Watch.
I think so.
So this guy is now called potassium permanganate anhydrous. So this lets us know that we boiled it off. The reason why we want to do this is because sometimes we'll do reactions that they can't have water present because water can be explosive, right? And so we may be using this chemical for another reaction. And so any little bit of water could cause a problem. By us saying that it was anhydrous, meaning that we boiled the water off. We're letting people know that we boiled the water off. It didn't come this way. We took the water out of it, okay? And by letting them know, because let's say you're not the best at boiling water. I mean, you're not the best at boiling chemicals, right? You didn't boil it long enough. It still had moisture in it. So then that person will take a little bit of extra precaution because they know that you remove the water, right? You guys understand?
Mm-hmm.
And so that's different than when you just have potassium permanganate, right? So if it's just potassium permanganate, that means that there's no water in it at all, right? There never was any water in it, okay? If there was water in it at some point, we have to use the word anhydrous. Okay, you see the distinction? Well, he obviously gets it. He's excited. He's like, I got it.
I have a question.
So you don't have to use the hexa for the 6?
Nope, the 6 now is separate. Like you see the dot here? So here
Oh,
means that's part of the reaction, it's part of the compound. Here means it's separated, it's plus. It's not part of the compound.
okay.
It's two independent moieties, right? They're no longer together.
Okay,
They split up.
makes sense.
They got a divorce. Okay? So then you just have, it would be potassium anhydrous and water, right?
Okay.
And those would be your two reactants where you have, so this would be a decomposition reaction, right? Because you're decomposing potassium permanganate hexahydrate to potassium anhydrous and water. Get it?
Yeah. Sorry, Jessica, I totally cut you off when you were trying to ask.
Oh no, that was my question. Thank you.
Oh, okay.
See, it was tag team.
Yeah.
Okay, so that big dot means that they're together, right? They're a couple, right? And so that basically means that you have water literally surrounding that atom or that compound, in this case, that compound. Okay, so you have, the top one has 6 water surrounding it. The bottom one has 8 water surrounding it. Okay, so each molecule of or compound of iron 3 chloride has 8 water surrounding it. Now, when you separate it, that means that you have just your iron chloride and water independent. They're separated from each other. In most cases, we turned it into a gas and it evaporated off, right? So, piece of cake, simple.
Yeah.
Okay, excellent, egg salad. Okay, so what should I tell you now? Oh, you guys ready to play a game, right? Shall we play a game?
Yeah.
Ready?
Yep.
Yes.
Okay, we're gonna have some fun. Okay, so this is how the game works. It's worth five extra credit points to your next text. I'm gonna list some things on the board, some names, and then you have to give me the chemical, the chemical formula for it. Okay? Are you ready?
Yep.
Yes.
Okay.
Yeah.
Okay, can you guys see them all? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, so this is how it works. You have to give me the name of all of these. The group that gets the most correct will get 5 points added onto their score. So the way this is going to work, you need to send it in to me via email. One person from your group send it in via email, and then we'll go over it. Okay? You guys get
I
that?
can't see the last one.
Okay.
After zinc, I can't see it.
Okay. Let me fix that.
There's like silver or something.
There you go.
Oh, there we go.
Okay. Are we ready?
How much time do we have to send it into you?
How much time do you think you guys will take? You know, I'm estimating a minute per name.
Huh?
A minute per
A minute per name?
um
Or do you need a little more time than that?
I think that should be fine, I guess.
Okay. So I'll give you guys 25 minutes total. Or should I give you 30 just to be safe? How about this? I'll give you 30. If you finish early, you come out.
Yeah, I
Okay?
think that works. Yeah.
Okay, so let's put you guys in groups. Okay, so let's start with the very first one. Delirious acid. Who's gonna go out on the limb and give me the chemical formula?
Anybody?
I'll try.
Okay,
So for the chemical formula, we got H2TeO3.
okay. And just because I'm old and everything, I may have not known that you were talking about an acid. I am just
Oh,
gonna
yes,
put that
And the
AQ
aqueous.
just to remind me,
Right.
okay? So what about the next one? Good job. Oh, any questions on this? Now, by not asking questions, that means you understand it back and forth. And I can give you the test right now and you'd be able to get that all right. Is that correct?
No.
Dr. Henry, we just put the H and we didn't put the aqueous in parentheses. Is that wrong?
It technically isn't wrong because I'm asking you for delirious acid. So you're just giving me the
Right.
chemical formula, but it's always best to do that because sometimes I may give you the chemical formula, right?
Right.
And if I give you the chemical formula and I don't put aqueous, you won't know that it's an acid.
It's
You
an
could also be
acid.
talking about a gaseous form of it, which is a covalent bond, and that would be done
Right.
differently. Your answers just came in.
Okay.
Okay, so we have potassium superoxide tetrahydrate. Sounds like something really deadly, doesn't it?
Mhm.
Did I not give you guys superoxide on your polyatomic ion table?
No.
I didn't. Okay. Okay, so let me give you that. That's my fault. My bad. You guys already probably looked it up, right? What did you guys get? Let's see if you guys agree.
O2.
O2 what? Negative what?
-2 or 3.
You said -3?
Yeah.
Because you're losing.
I think because you're adding.
So superoxide is a very, very special case. So it's O2 negative, right?
Oh.
It's actually, each of the oxygens are going to be like a half. So it's like this. That's what superoxide looks like. Hot mess, isn't it?
Yeah.
So each one is going to be a half of a molecule. Peroxide means it would be O2, 2 minus. So that means each one is worth 1, right? You guys see peroxide on your table?
Mm-hmm.
Yeah.
So each oxygen is kind of like a -1. Here, each oxygen is like a -1/2, which is crazy. So that's what superoxide looks like. So if I have potassium superoxide, then what should it look like? What would be my answer?
Okay.
Two negative
Okay.
times 4H2O.
Big fat dot. And you said 4H2O?
Yes.
Excellent. That's exactly what it looks like. That is the chemical formula. I should say what it looks like. We're not drawing the Lewis dot structure yet. Okay, so what about this guy? Show me the Lewis dot structure for it. You can also give me the chemical compound, but what would be the Lewis dot structure for, the structure for it? That's a lot easier to see than that.
So your longest chain would be 3.
Mm-hmm.
Okay.
Go ahead, Deandra. You got this.
Yeah, so your longest chain is 3. And then it's telling you that on the 2 you have a methyl, so it would just have one line going off of the 2. But then the NaL at the end of propanol tells you that it's an alcohol.
Is that an alcohol? That's an Al, not an OL.
Oh, not an OL.
Ooh, yeah.
Oh, goodness.
You fell into my trap.
Can I jump in?
Yes, Judy, jump in.
So your Al, I believe, is your not your alcohol, but your acid.
Nope. It's not an acid.
It's not acid.
Nope.
It's what the hell? Well, this is what I wrote. This is what I wrote. I did the 3 carbons, but I also have like a double bond to O, and then I have another carbon connected to an hydrogen, and then a methyl coming off that too.
Ooh, you got carried away, didn't you?
Yeah, something like that.
So this is the way it looks. It has an H off of it, right? Here you want to show the H since it's an anhydride, or you could draw it like this. Since it's an aldehyde, not an anhydride. You could also draw it like that, where this is a double bond here, and double bond to the O, and it's understood that there's another hydrogen coming off of here, or you can actually just put the hydrogen to make it easier for old people like me, right? So this tells me it's an aldehyde. So Al means aldehyde, right? So the structure for an aldehyde is, circle it in green. This guy here, right? Where this is the hydrocarbon that's associated with it. You guys get that? How many carbons we have? 1, 2, 3. We have a methyl hanging off of this 2, since this will be our first carbon. Okay, and then this is the aldehyde structure. Okay, piece of cake? So If I wanted to write the chemical formula, what would be my chemical formula? So see what? How many carbons will we have?
3.
3.
1, 2, 3, and what about the one up here?
4.
4 carbons. How many hydrogens will I have?
Oh my.
1.
So there's how many that'll be surrounding this carbon to make it 4 attachments? Come on, you guys, we did this. This should be like, remember, bread and butter. You should be doing, I got this, right? Here, I'll get my nails done while I'm telling me the answer, right? That's what you should be doing. Okay, so this carbon, since it's a single bond right here, how many attachments will make it have 4 attachments?
3.
3. So I need 3 hydrogens, right? For that one.
You from Mickey Mouse? And the
And
baby.
what about this one
Where's
here? Which is
Lily?
this one here?
3. 3.
3, another 3. Another
Play.
3 hydrogens. Then this one here, it has 1, 2, 3 attachments. How many more to make it so it'll be 4?
1.
1. And then this one here has this hydrogen, and then double bond, that's 1, 2, 3, so that's already 4. Right? So added it together, that's what?
8.
And then we have a single oxygen. So that would be the chemical formula. Piece of cake?
Piece of cake.
Piece of cake. You just break it down. Remember, carbon wants 4 attachments, right? And the double bond counts as 2, so it needs, that's your other 2, okay? Triple bond counts as 3, right? So it just needs 1 more. Okay, so let's do the next one. So what does the structure look like? I'm going to erase this, our count here. Okay, do I have to volunteer somebody? Come on, give me some volunteers. You guys, why you guys act like you're shy? You know you're not. I know Judy's not shy.
Go away. Can I talk?
I can try
You want
it.
me to
Oh,
also talk?
go ahead.
No, I have someone else talk.
Okay, Jessica, tell me.
I don't know if it's right, but we got an O as the center atom.
Oh, excellent.
And then on the left, we put an ethyl, so we just have a branch coming off with 2.
Okay. Or, sorry,
And then on the other side, we have 5.
1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So that is excellent. Good job. I don't know if I'm right. Okay. So let's figure out how many carbons we have. How many total carbons do we have?
7.
You said 7? Sounds good to me. So we have 7 carbons.
7.
How many hydrogens?
That'd be times 3, 21 of them, maybe?
Well, so there'll be 3 here, there'll be 2 here, there'll be 2 here, there'll be 2 here, there'll be 2
Okay,
here. So that's 2, 4, 6, 8, 10. And then we have 3 here and 3 here. So 16. Is that correct? Because remember, 4 attachments. So this same carbon, to make it have 4 attachments, it needs 3 hydrogens. So we'll write that down. The center one has 2 attachments already. So then how many more will it make it complete for its 4 attachments?
2.
Okay. This one is also going to be the same, right? Or this one's going to be the same. This one's going to be the same. This one's going to be the same. This is going to be the same. So that's 1, 2, 3, 4, and that's 5. So 5 times. And then we got 2 that were in. So we go 2 times. So that's 6 plus 10. And that's a total of what?
16.
16.
Dr. Henry, please, I have a question. I am trying to figure out how to locate where the hydrogens.
Okay. Hydrogens are real simple, right? Because hydrogens are used to complete the 4 attachments rule, right?
Yep.
So this N here is a carbon, right?
Yeah.
So how many attachments does this carbon have that you see visually?
2.
It has 2 attachments. This one right here, this one at the end, because that's a carbon right there. It has 2 attachments that you see visually, because it's attached to what? This carbon.
Yeah.
Is that 2? Or is that
1.
1? That's 1, right?
Yeah.
So then how many hydrogens are going to be needed to be attached to that carbon so that we have 4 attachments total? So if I have 1 attachment here, so that it equals 4 attachments, how many hydrogens will I need to be attached to? What plus 1 equals 4? What number plus 1 equals 4?
3.
3. Okay, so that means that at the end here, I'll need 3 hydrogens attached to it so that this carbon has 4 attachments, because carbons are whore, okay? Carbon likes to have 4 people around it or 4 attachments around it.
Okay.
So a double bond counts as 2 attachments. Another atom counts as 1 attachment if it's a single bond. Okay. So here, that's 3. So every end, that's going to be 3. So we have 2 ends. Now what about the one in the middle? So this carbon here, this C right here, how many attachments does it have that you see, that you visually see? So if this index is a C,
2.
2, okay? So then how many more will it need to equal 4?
3.
So you're telling me 2 plus 3 equals 4?
Oh no, 2. 2.
2.
Sorry.
Okay. So 2 plus 2 equals 4, right? So then that means that we have those 2 hydrogens. So that means that this guy would have 2 hydrogens, 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 and this guy would have 2 hydrogens. So that's why we said 5.
All right.
Okay?
Thank you.
No problem. Okay, piece of cake. And how many oxygens do we have?
1.
1, right? Gosh, you guys make me work really hard for that damn 1 hot oxygen. Come on now. I'm already having a bad day. Don't make it worse. Don't make me go home crying. I mean, I'm already home, but don't make me cry in my own house. Okay, so the next one. Don't be scared. There's no reason to be scared now.
I can try the next one.
Okay.
Okay, so since there's is it the pent-3-enoic acid or the isoheptanol?
Oh, it's the pent. Yeah, it is the pent. So we'll draw it out of here. We're running out of room over there. We're all getting grouped together. And so you guys know that goes with this, and this goes with this. Okay, so let's go ahead. Come on, Selena.
So since there's that Greek prefix pent, you would have 4 carbon chains, right, for your structure?
Pent. Would it be 4?
Oh, 5. Oh wait, yeah, 5.
1, 2, 3. Wait, 1, 2, 3, 4, 5. Okay, I got 5.
Okay. And then next you have that 3-EN, and now
Mhm.
let's make there's somewhere in that structure there is a double bond, and it
Okay.
happens in the third carbon.
Okay, so I'm going to put my carbon. I'm going to start from, because I'm kind of visual and I like to do things kind of consistent. So let's see, that's 1, 2, 3.
Yeah.
So I have a double bond here. Okay.
And we know that the structure is also an acid.
Okay.
Include that double bonded oxygen with the single bond with another single bond of oxygen. Like I can't explain it, but like I need to like visually see it.
Like this.
Yeah, and then after that there's a single bond of hydrogen for it to be
Okay, like that. So I always just don't draw that single bond. I just draw the OH to make it easy for me to see. But if you draw the single bond, I'll accept it because it's really a bond there. Okay, good job. Looks beautiful. Now, let's count. How many carbons do we have? 5 carbons. How many oxygens? Or
1.
hydrogens. Sorry, let's start with hydrogens.
So 3, 9 hydrogen? Oh, 10 hydrogens.
Okay, so we have 3 here. We have, let's see, that's 2 attachments, so that's 1 here, so that's 4. So let me write that down. 3 plus 1. We have 3 here. I mean, 1 here, sorry. 1 here. And then we have 2 here. And then this guy has none because it has already 4 attachments. And then this guy has 1. So let's add that together. What, 8? Is that correct?
Yeah, 8 hydrogen.
Okay. How many oxygens?
2.
That is correct. He got upset about that. He's like, I wanted to answer the question. Damn it. You beat me. Okay. Here's the cake. What about this guy here?
Okay.
Would that have 7 carbon chains?
7 carbon chains. So that's 1, 2, 3, 4, 5, 6, 7.
Right.
And
Is
then
that right?
in the center would have the OH.
Oh, that was so easy. Okay. So then chemical formula. How many carbons?
7.
How many hydrogens? So how many will we have here? At the end, how many attachments does it need to make it complete? So it will have 4
3.
attachments.
3.
3. And then this and here, same thing, right?
Same.
So let's multiply that times 2. And what about these center ones? Here and here, here and here. So right here, how many will we have to make it complete?
2.
Okay. So then that's times 4. Then we have this carbon here. How many will it has to make it complete with 4 attachments?
1.
1. Okay, and then we also have the one on the OH.
15, 16.
So that's 8. That's 6. And then this is 2. So 16. Okay, how many oxygens?
1.
Okay, piece of cake? Anybody want to buy me a shot? Piece of cake, right? I want a birthday cake shot.
Is it your birthday?
No, my
Is it
birthday
your birth-
my birthday's Valentine's Day, but you know, I celebrate my birthday year round.
There you go.
Okay, so what about this guy? We'll put it over here in the corner. Somebody other than Selena, Jessica, Judy, and Kayla. Don't be scared. Nothing to be scared of. Come on.
Or are we doing hyposelene ion?
That's correct.
Okay. Would it be Se2 to the -2?
Se2. Okay. Are you forgetting something?
To the -2?
To the -2. So you're saying Se2 to the -2. Would it be Se2? What does this mean? That ITE mean? And ATE. What do they always mean?
I means that it's going to end in us.
Well, that's if we're talking about acids, right? But in general, what does it mean? What are these guys called? ATE, ITE, they're called what?
Acids
They're called acids?
or polyatomic ions.
They're polyatomic ions. What type of polyatomic ions? They have a specific name.
Dr. Henry?
Yep,
This is in regards to oxygen, right?
that's right. So
Okay.
anytime you see an ITE or an ATE, except for there are 2 cases that are on your periodic table, but anytime you see that, I mean, at your periodic table, there are 2 cases on your polyatomic ion table. Anytime you see that, the first thing that you should say is it has to have oxygen in it. Does this compound that you have here have oxygen in it?
No.
No. So it needs to have oxygen in it. Now, when you looked at sulfate, what does sulfate looks like?
SO4,
SO4. What does sulfite look like?
SO3,
SO3. What does hyposulfite look like?
would it be SO2?
That's correct. So you have the 2, but you're having the 2 next to the selenium, right? And that's not the case. We want to put Se.
SeO2?
That's right.
Okay.
Okay. So always remember, ITE means that there should be an oxygen in it because they're called oxy and ions. So think about the names of things. It kind of helps you out. Okay. ITE, ATE. There needs to be oxygens in them, except for a couple of cases. And I want you guys in a minute to tell me what those cases are. Actually, there's only one on your polyatomic ion table. Let me put the other one up there. Okay, next one, next question.
Okie doke. So Fe, and then you would put in parentheses your hydrogen carbonate formula.
Okay.
but then you need to notate that you have 3 iron, so you put the 3 behind the parentheses.
Okay, so what does the hydrogen carbonate ion look like?
So it's going to be FeHCO3.
Is it O3? Carbonite.
Okay, so it'd be HCO2.
Okay. And you said 3 down here?
And then 3 behind the parentheses.
There we go. Good job. Nice recovery, Matt. That's the way.
Thanks.
Good job. You guys are starting to make me proud. I'm going to start crying here soon. Next, come on, next victim. Or do I have to pick somebody? Because I will call you out. Come on, Andy. Gonna volunteer? Again, it's better for you guys to get this wrong now with me here so we can work you through it than you get it wrong on the test when I'm not there. Or when you're in the hospital, giving the person the wrong drug.
Would it be Mg3N2?
M, G, 3, and 2. That is correct. Who is that?
Me.
Who is
Leslie.
me? Leslie?
Yeah.
Oh, right, Leslie. That's the way. Keep it up. See, you guys, I'm going to go up in tears. You're making my bad day get better already. Look at that. Come on, keep it up. Good job.
As a SpO3 negative
For which one?
for hypochlorite acid.
Hydro? You mean hydro?
Yeah.
Hydro, anti. Okay, so you said, say it again. What were you saying?
As a SpO3.
SB. It's SB is in there, but what does it say? This is hydro. We have hydro in the front of it. So that means what? As soon as you see that, and we have ick. My ride has hydraulics.
Oh.
So you're right, the symbol is SB for the antimony, right? So, but it has hydro and ick. So do I have oxygen in that case when I have hydro and ick? Anybody want to help him out?
No.
Negative 3.
What was it?
SpO.
SBO? Are you sure there's an O in there?
No.
That's what I got. Let me see again.
What?
Let me check let's see again. What the?
My ride has hydraulic. So if I have sulfide, it's called hydrosulfuric, right? So
Right.
isn't this sulfide? Isn't this what sulfide looks like?
Which one are you doing it? Hydroantimate.
We're doing this one. We skipped one, but that's all right. We'll come back to it.
Oh, I skip already?
Yeah, but that's all right. Don't worry about it. Worry about this one that we're talking about. So in this case, sulfide will make hydrosulfuric acid. So if I have hydroatomic acid, then what must look at the similarities. What am I going to do in this case? So this guy is hydro,
Hydro. What is it? Hydro. Who's antimagic now? That's my antimagic.
okay?
Wow,
So you see that, right, Andy?
my bow out now.
Can you see my screen?
Yeah, I do. I see a
Okay.
screen.
So what do you need to do for hydroatomic acid?
Because I put all the, I pre-antimate, and then I do an hypochlorite.
So you
And
telling me I
acid.
need to do what? What do I need to put in front of the antimony?
I don't know. Acid?
I'm writing it, so I have SB. So is there something that should go in front of it? Look at it.
Can I say something?
Oh, wait, no, wait a minute. Is a H2X.
So
It's
would it be
H2.
H2? Or would it be,
Yeah.
are you sure it's H2?
That means H3 then.
Why is it H3, Andy?
Because they have 3 and then behind it.
Okay, so if we look where antimony is at on the periodic table, right? How far is it from being a noble gas?
Let me see. Noble gas.
A noble gas. How far is antimony from being a noble gas?
3.
Did you say 3?
Yeah, I did.
Okay.
How many?
So it's 3 away from being a noble gas. So that means antimony would have a -3 charge, right?
Right.
Yeah.
So then it needs 3 H pluses to balance it out. So
3.
it equals 0.
Right.
-3. Yeah, 3 more.
That's right. Okay, piece of cake?
So, because I need 3 more, that's why I have to put HT to be a noble gas. And
That's
then,
right. So
got
that
it.
it'll equal 0. That's right. Because we want it, at the end of the day, we want it to be 0 because it doesn't say ion at the end of it, right? So it needs to be a 0 charge overall. And so we need that 3, we need 3 of those hydrogens to balance it out for that acid.
Okay.
Okay, good job. Took us a little bit, but we got there. That's the important part. Okay, come on, who's next? Who's the next victim? I mean, volunteer.
Victim.
So the
Come on, this is-
hydrofluoric acid, wouldn't it just be HF and then
That's right.
AQ?
That is correct.
So it's just 1 till it becomes a noble gas.
That is correct.
We missed 1.
Oh yeah, we skipped magnesium azide.
Okay, yes, let's go back up to magnesium azide.
H3.
Okay, what does magnesium azide look like? Anybody?
And 3
Magnesium
negative.
azide.
MG.
M,
Would it be MG,
MG.
N?
M32.
We'll put this one over here. He said MGN what?
3.
MGN 3.
3, 2.
Is that it?
And then a 2 at the end.
Okay. That would be correct. Or you would actually write it like this. MGN6. Okay. I'll accept both of them under the circumstances, you know. That 2 makes it a whole lot easier to understand, right?
Yeah.
Okay. What about this guy, fluoric acid? Boy, we run out of room fast.
Would it be HFO3 aqueous?
H
1, 2.
F
2 amino.
O3 aqueous. That is correct. Okay. Come on, some of those silent folks. Let's see. Acetic acid.
Okay.
H. And then it would be C2. H3O2 aqueous.
Okay, piece of cake. Okay, hypoboreous acid.
Is that asco?
Oh,
No, it's gross. I don't like that place.
H3BPO. Ah, now I know this one. One,
H.
1, 2, 3. Two level gas. To be in a
You said BO.
1, 2, 3. 1, 2, 3. Yeah, BO. BO, yeah.
Okay.
H3BO. And
Okay.
it's
And
no,
then how
it's
many hydrogens will I have to balance it out?
1, 2, 3.
3. That is correct, Andy. Good job.
The only thing I don't understand this one. You know the magnesium azide.
Azide. Yeah. So if
Yeah.
you look on your if you look on your polyatomic ion table, right?
No, where can I get an N to it?
Look on your polyatomic ion table.
Yeah.
Look at azide. What is azide?
Oh, azide. Oh, okay.
Yeah. So sometimes that's why I said always look on your polyatomic ion table, right? Because that's going to help you out. Sometimes you have azide, right? Those are your special cases. Remember superoxide earlier? That was a really special case, right?
Okay.
So kind of pay attention to those because sometimes the ions that are formed are very special cases, okay? So you want to pay attention to that, okay? So the last two, what are our last two? Zinc 4, phosphate, and hydrous.
Would that be ZN?
Somebody was talking robot. Try again, please.
Would that be Z?
Robot.
ZN, I heard that. If you could put it in a chat, that may help us out a little bit. ZN, I heard. And what does phosphate look like?
PO4.
PO4. How many phosphates should I have to balance out the zinc 4? And how many zinc should I have to balance out the phosphate, which is what charge?
Let me see.
I heard somebody say it. Maybe I'm hearing things. Oh, somebody, there you go. I see it in the window. Good job, Selena.
Good. 3, 1, 2, 3.
So the only thing is that there won't be any oxygen. No water. So all you'd have to do is write it as this, right? And you don't have to put the water on the side. We only put the water on the side when there's a reaction. Do you understand that, Selena?
Yeah.
Okay. So you just write it like that. Okay, what about silver nitrate pentahydrate?
AG. And then nitrate is NO3, so nitrite would be NO2.
Okay.
And that would be times 5H2O.
Okay, dot 5H2O. That is correct. So did you guys get them all right?
No.
Did anybody get them almost all right?
Dr. Henry,
Yes.
Sorry. The zinc, the anhydrous, if we, because, so you're saying that we don't need to put the H2O there? If we put a plus H2O, would that still be accurate?
No, because so even though, okay, so you would just only want to put the zinc, because we're talking about just the zinc component of it. If I said anhydrous plus water, you know, then you put water, right? You put plus water. Since we're not telling you that, you just want to put what anhydrous means, right? It means it doesn't have water in it. So you're just talking about that component. Do you understand?
Okay,
so even
and
though
that would be accurate for, I'm sorry, go ahead.
Even though anhydrous means that the water has been removed, right? That doesn't mean that I'm sending you water and this, right? When I say anhydrous, I'm just sending you that chemical, just the zinc phosphate. That's all you're getting. I'm keeping the water, but I'm just letting you know that I sent
water
you.
included in it.
That's right.
Okay.
And so you would only, so when you write the chemical formula, you only want to put this. You don't want to put the water part. Okay. So if they ask you that, but if I ask you for the equation, if I say, if you're going from zinc hexahydrate or zinc 4 phosphate hexahydrate to zinc zinc 4 phosphate anhydrous, write the chemical equation, then you put the water in there. Okay. So if I ask you for the chemical equation, that means everything. That means you need to put that in there. But if I just ask you for the chemical compound or the chemical formula, then all you need to do is just put that chemical formula. You guys get that? Because I always put one question on the test in terms of nomenclature that I ask, particularly for acids. Give me the acids and the oxyanhydride reaction that will occur with this acid or something like that. So I want the reaction or the decomposition of this acid, meaning they're breaking apart, right? The ions are breaking apart. So I want to see those ions. I always ask a question like that on the exam. And then I'd say, name all the components. Okay. So if you have any questions about that, I'm sure Jessica can go over it and tutorial today. Questions, concerns, Cash? What was that?
I said when you said, and then you would ask what the components are, that means like when you have the little parentheses and you have gas and liquid, that is what you're talking about? Okay.
Well, not only that, I'm asking you for the reaction. If I ask you for the acid reaction or the acid dissociation reaction, that means that you have the acid, it's dissociating into its ions. So what is the ion that it's going to make? Okay, so let's say, for instance, I said, write the dissociation. I'll type it out so you guys can understand what I'm asking. Dissociation reaction for hypo.
Okay, that works.
Okay, so I'll write something like that. Then in that case, what you're going to do is you're going to write the acid, and it dissociates into its ions, right? So what two ions is it going to dissociate into?
Hydrogen and the borite.
Is it borite or is it something else? So we have the hydrogen ion. I'm going to put AQ. Plus what is Boo?
Hypoborous?
Hypoborite. That's right.
Oh, I see it. Okay.
Okay, do you guys see that? Okay, remember, ions, when they're put in water, they're going to dissociate, right? So that's what I mean by dissociate. They're going to separate into their part, kind of like salt. Salt becomes Na plus, Cl minus when it goes in water, right? Okay, piece of cake?
Yes.
Okay, practice this because nomenclature, like I said, if you can't name the chemicals in the reaction, how in the hell can you sit there and balance in the equation? How can you calculate how much you have if you don't know what you're starting off with? Okay. So it's a very, very important part of chemistry. Okay. So, and if you're scared of this, like if you're one of the persons that didn't answer a question, right? Stop being scared. There's nothing to be scared of. I yell, yes, I do yell. And I will constantly yell. And I'm like, you should know this already, right? I'm going to say that because you know it's the truth. So if you don't know it, then you need to take the time to know it, right? Again, it's better for you to be yelled at and be wrong now than in the hospital or in a field or something like that, or on an exam. You know, although exams are important, those other things are much more important. I would hate to have one of you guys administer the wrong drug to a patient, and then you go back and say, well, yeah, I took Dr. Henry's class, you know. I'm like, no, they didn't take my class. I'll deny you in a heartbeat. Never saw that person in my life. Okay? So it's important. This is very, very important, okay? So take it seriously. Because if you're not taking it seriously now, you're not going to take it seriously, you know, when you're going through your nursing program and you're filling all your drug tests, you know, not your drug test, not your pee drug. You know what I mean? Okay. Any questions? Sorry it took a while, but like I said, this is what it's funny, but this is like one of the most important part of chemistry. It is so important. So important. So you want to make sure you got this.
He just spit up all over me.
See, he was letting you know it's important. He's like, hey.
I know. Never fails. Oh,
okay.
Thank you.
So I'm also going to show you guys these. So Maribel actually has flashcards. You guys see my flashcard? Is it showing backwards to you guys, or is it showing the right way?
The right way.
Okay.
Well, looks calcium acetate.
Okay, because on my screen it's backwards, so it's kind of weird. But so flashcards help, right? Hers are $26, so they're a little pricey. I wouldn't spend $26 for them. The only reason I did it is because I wanted to see the product that she's making. I typically always.
Where do you order them from, like Amazon or?
Actually, if you go to the links channel, he has a link to that channel. She'll send you a little packet that you can download, and also another link to her products.
Oh, okay.
She has class notes for everything, but she charges you way too much for class.
How do I access to it again?
To her channel, if you go to modules.
Oh no, to the flashcards. Is it in the module?
It's not in the It's not in the modules. You'll actually have to go to her channel. She has a link there on her channel to just her personal sites where you can buy her products.
And it's in the modules, the name of the person?
Yes, it's a link, Maribel's. So it's one of Maribel's. Her last name is Maribel. It's Melissa Maribel, right?
Oh, okay.
Okay, so go to
you know
that
the product
link.
name again?
If you look under, I don't know the product name off the top of my head. If you go under her channel, look under her channel. So Melissa Maribel, look under her channel. She has a link that will take you to all of her product stuff. Click that link, and then you'll be able to get that information.
Okay.
Okay?
Oh, somebody put it on there.
What was that?
Somebody already put it in the chat box.
Okay.
They're so fast.
Oh my gosh. Not again. No.
So I don't know her personally. I'm not trying to sell her items or anything like that. But I just like her style. It's kind of fun, you know?
Mhm.
So. And then sometimes you guys don't get what you need from me, so you're able to get it from her, you know? Or yourself. Okay. Any other questions?
Yeah.
Am I at home? Yes, I am at home.
Doctor,
Yes.
you know, how can I go to see, you know, like, see in the test, you know, I try to do the, what's again? Okay. No, I try to do the, what, test one correction, you know, where can I go? I go to the,
Oh, let me fix that. After you finish your test one corrections, so to see your test, so you've done your test, and some of you guys, I need to finish grading them, but you should be able to see your answers. You can already get started on them. But I didn't do your short answer parts of it, some of you, because I know you had trouble uploading it. So what you guys need to do is go to your grade. You go to your grade, click onto your grade, and then click onto the exam, and then it'll show you everything that you missed. Okay? And then so you can actually get started with that. So you'll actually have, you'll have until Thursday to get me your test correction since I screwed up and I had you guys
I
locked
think it
out.
says it's due today.
I will adjust that. You have until Thursday to get it done, okay? So I'll adjust it right after this class.
I think it's still locked on my door, doctor. It's still locked.
Yours is still locked? Okay, Andy,
Yeah.
I'll see why it's locked. I'll give an answer to you by email,
Okay.
okay?
Okay, thank you.
No problem.
Dr. Henry,
Actually, I'll give you till Friday to get it done. Yes. Yes, Aaron?
Yeah, we have just one slot to make use of this test correction.
Yes, you have one opportunity to do a test correction, right? So you can't do a test correction for everything. You can only do it for one exam. It only will count for one exam. You can upload them. You can upload 4 test corrections, but I'm only going to look at that very first one you did because that's the one you said you chose, right? I'm not going to look at them all. Okay.
Okay.
So be smart. Be smart on how you use it. You know, it's all strategy. Life is strategy.
Mm.
Okay.
Okay.
Any other questions?
We can submit that through the syllabus, is that correct?
You should be able to submit it through your syllabus. Yes, it's uploadable. Yes.
Great, thank you.
Okay. Any other questions? Now, and you guys remember, you're only correcting the ones that you got wrong. It's not the whole test. Unless you got the whole test wrong, then you need to do the whole test. Okay?
Okay.
No other questions? Okay. Oh, he's just ready for chemistry. You can tell. Get him started early. You know, his first words are gonna.
You gotta teach him young, huh?
Exactly. He's gonna start saying isohexanol. And, you know, that's what are gonna be his first words. He's not gonna say mommy or daddy. He's gonna be spouting chemical formulas. Okay. Okay, so then I'll see you guys tomorrow. Again, we'll try to get you guys a solution, quick solution for the labs. I have to try to get in contact with my boss, try to work things out, but we'll get that done. Okay.
Who got the extra credit?
Oh, I'll let you know who got it. I have to look at all of the answers.
You'll email us or let us know tomorrow?
I will let you know. I will email you and let your group know that you guys got it. if you got it.
Okay.
Thank you,
Okay.
Dr. Henry.
I'll see you guys.
Alrighty, we'll see you tomorrow.
Have a
Thank
good
you,
night.
Dr. Henry.
Bye.
Good day.